Hello, everyone. I don't know if you could hear me before, but once again, thank you for joining us today. My name is Askia. I'm one of the event coordinators for the Redmond Reactor Space, and I will be sharing some resources with you here. So please, if you could take a moment to look at our code of conduct. And basically what that is saying is that we seek to provide a respectful environment for both our audience and presenters. We definitely encourage engagement in the chat, but we ask that you be mindful of your commentary. Please try to remain professional and on topic. Typically, we'll share useful links throughout the chat, so keep an eye out for that. And this session is going to be recorded and will be available within 24 to 48 hours on the Microsoft Reactor YouTube channel. With that said, I will bring our speaker on and enjoy the session.
Hello guys, good afternoon. Can you see my screen okay?
Yes.
Perfect. Thank you for joining this session, and today we would be talking about multi-agentic framework paired with Semantic Kernel and AutoGen. Just a couple of lines about me. So I am a Microsoft AI MVP. I am an AI specialist at Avanade, Australia, and you can interact with me on my LinkedIn handle or my Twitter or my Medium blog. So after the Ignite announcement, right, which was centered fairly around agents, this was the takeaway that agents is going to be the next wave of AI revolution. Last year we had Copilot extensions, and now those are evolving to autonomous agents. Okay. So before we jump on to an agent, an agentic framework or agent architectures, just let's have a look at what's an agent, right? So you might see some fairly complex data science representations of functions and agents and actions and some percept maps and so on and so forth. Okay, so that's just the data scientist in me trying to make it more complex than it really has to be. So if you just simplify the math, what it means, okay? So it means that an agent is an entity, okay? It's an entity could be, piece of code, a script, a low code kind of, logic, okay? Low code, no code logic, right? So it's basically a functional piece of logic which can actually take inputs from its environment, what we call it as percepts, right? So that percepts helps it to establish context, and based on the percept which it receives, it could be a single percept, it could be multiple percept. Based on the percept which it receives, it is able to then take actions. It is able to be reactive. It can also be proactive. It can think, okay, it can comprehend, and then it can decide on the course of action. So here, as you can see, right, it can have decision making, planning or reasoning. It can learn, okay, from the past interactions based on your reinforcement carrot stick approach, okay, reward and learn approach, okay, reward punishment approach. So it can learn, it can retrieve knowledge, it can have a recall from its memory based on the past actions, and then it can decide the next best course of action. Okay, and this is not this is not out of the box in an agent. This is how we program those agents to be able to then accordingly take actions and then react to the environment. Okay, and then now last couple of years ago or maybe a year ago, it was all about RAG applications, and then now come agent, it has all turned into agentic rags. So if we just try to simply tabulate the difference between rags and agentic rags, what it means. So if you look on the extreme left hand side, okay, the applications, the chat applications which you interact with, like chat.openai.com or your Bing chat or your M365 workplace or web chat. Okay, what basically happens is you have an LLM at the center. Okay, you have all the data, all the public data or whichever data the LLMs was trained on. The query which you are entering is your prompt, and the answer, like for example, I can ask questions like why is the sky blue, or for an M365 Copilot the workplace chat, I can ask something like can you fetch me the last presentation on XYZ topic from my OneDrive. those kind of things, or from my shared drive, those kind of things, right? So that's the prompt and answer which you get. Now the RAG concept comes where, apart from just the prompt and answer, you give the LLM context of your data, your enterprise data. So it could be, let's say, your websites, your bank specific compliance policies, HR policies and documents, but then you make it forget all the other context on which it was trained on, and you ground it with your context, right? This is a grounding data which you give, and that becomes retrieval augmented generation. So basically prompt LLM, but the context which you give to the LLM is your own enterprise data, and then accordingly you can get the answers. And one of the most compelling use cases which we saw with RAG was your knowledge mining, knowledge search kind of use cases, or conversational bot use cases for your enterprise data. Now, with agents, as you can see, the architecture further evolves, and alongside your prompt and context, it also has a memory. It also has some tools, okay, tools which enable it to store context, to have past memory, tools which enable it to define and dictate the actions it can take, and it has reasoning capabilities as well. Okay, so these agents are basically skilled units which can navigate multiple documents, they can synthesize information, they can provide comprehensive and accurate responses, okay, and they can also decide on how to reason. Like there's no one set line of reasoning, it can take different courses of action to actually get you to the end result, okay. And basis the type of tooling and reasoning capabilities and the goals on which they are trained on, we have different types of agents. You have reflex agent, with state, we have goal based agent, we have utility based agent, and we have learning agent. And the modern applications which we build with the autonomous agents are a combination of one or more of these agents, right? Okay, so right from the most simplest one, the reflex agent, down to the complex one, which is utility or learning based agents. So modern applications are a combination of these, okay. Now before we can go into actual demos with the single RAG or agentic rags and the tools for developing agentic applications, let's look at the most common question which is always asked about the frameworks for building agentic architectures, right? The frameworks for building and orchestrating agents, okay. So when we say that agents have this beautiful capacity of reasoning and negotiating with each other and deciding on the course of action, what actually facilitates that? What enables this back and forth between agents? How does an agent know that, hey, I'm supposed to pick up this task, and I'm supposed to execute this action? There has to be some framework that orchestrates this handoff between different agents, right? And right now in the Microsoft ecosystem, we have two of these robust frameworks, Semantic Kernel and AutoGen. Now, to be fair, this demo was presented just before Ignite, so Semantic Kernel Processes was not yet announced that time. But now we also know that Semantic Kernel Processes is around, and it is compatible with your AutoGen functions and schema, and then that is also one of the frameworks for your orchestration of multiple agents, okay. But when we talk just about semantic kernel, so semantic kernel, as you can see, it's a framework which is equipped for creating single RAG applications, okay. So this is it is creating one single agent, and semantic kernel is then equipping it with tools and planning and memory and plugins to execute certain actions. Okay, so multiple agents are there, right? So one could be an agent which is actually searching your web data. Second could be an agent which is actually responsible for searching confidential PII data in your on-prem databases. Third could be an agent which is actually summarizing the information both those agents fetch and then hand off to the main agent to actually then give it back to the user. So these are the different agents which are built using semantic kernel, and the orchestration between those agents will be a framework which will be built on top of AutoGen, okay. So AutoGen then accesses real-time information between these different agents which are built using semantic kernel, and they can communicate effectively, okay. So before we go on to actually, agentic architecture, let us look at a particular, semantic kernel enabled single agent demo. Then we look at some of the shortcomings and the need for multi-agentic handoff, right? And then from there on, we will look at the code of multi-agentic demo and see it in action. All right. So let's have a look at our. So this is a demo in which this is a claim lodgement process. Okay, so the user is actually giving some details about his accident directly to the AI bot. Okay, so it's a neural voice. Okay, and it will be then able to help the person to actually lodge the claim. Okay, so let's start with the demo. Of course, we need not see the full demo. I'll jump onto the important pieces as and when needed.
Hi, Andrea. Welcome to ABC Insurer. I'm Charlie. I am here to help you navigate around our website. Just ask me a question.
Hey Charlie, I've been trying to get around your self-service portal and I can't find anywhere on this site where I can actually lodge a claim online. Can you help me with this?
Sorry to hear that, Andrea. If you like, I can fill parts of your claim lodgement form.
Sure, if you can do it.
Okay, before we can start, I need to confirm the policy we will be lodging.
So then, as you can see, this bot is helping the user log his accident details for insurance claim. Okay, and then she's confirming a few details on his policy, right? Okay, yeah. So then, based on the information which the user gave to her, she has filled out the form. Okay, as you can see, his car, and then some of the information around that. So then while making a claim, she's also helping. So what happened, when and where, approximate time, post code or suburb where it happened, all those details. The user told her she has actually pre-populated it. Okay. And then what was the damage? Okay. What was the damage done? That was also pre-populated based on the description. Okay. And then if they have any additional documents to verify the accident, like any photos or other things, then that also we can actually then add. Okay, and these are the policy details of that particular person. And then that's all. Then he can just log the claim and we are done. Okay, then she has actually summarized the conversation, sent a mail, so on and so forth, right? So pretty seamless process when it comes to uh, single agent architecture. Perfect, right? Now let's come to the issue of this particular single agent RAG architecture. This was a case where this particular agent was just supposed to help with lodging the claim details, right? Okay, so this particular agent was just helping to lodge the claim details. Okay, imagine a case where now the user has to actually no, not user, the agent has to actually have access to the user's confidential data. Okay, so I will establish that with an example, right? So for example, imagine a banking scenario. So you are end user and you're calling the bank contact center, right, with the queries regarding credit card. Okay, so imagine you're calling the bank. You already have an account with the bank, a loan account, mortgage account with that particular bank, and now you're asking the bank that, hey, based on my spending pattern and based on my account profile with you, can you suggest me a credit card which is more suitable for me, right? So in that case, you see what has to happen. The agent, the AI agent, has not only to have information about banking products. Okay, so your credit card products and your insurance products and all of the other products of the bank, but then it also needs to have information on the particular customer transaction data, which is sensitive data, right? And then there is a need for us to then probably have a separate LLM call, and then orchestration between two different LLMs to actually send one part of the LLM to fetch your non-confidential data like the banking documents and websites and products related data, and then another LLM call to actually go back to your confidential data zones, fetch the customer profile, loan account data, so on and so forth, and then combine these two pieces together. So imagine the amount of orchestration that has to do from the front end. The query has to be broken down, it has to be analyzed, which parts have to be sent to the agent for website data, which part has to be sent to the agent for actually fetching your on-prem sensitive data, so on and so forth. And all of this orchestration, if we decide to do it ourselves, that's a overhead for us, right? And then also the accuracy of all this orchestration and model switching and intelligent model selection dynamically is a problem. Okay, so this is where your multi-agentic frameworks then come. And this is the flow for a real-time contact center personalization query, right? So this is an actual use case which we had done for one of the banks, right? And they had all their confidential sensitive data on-prem, so customer data, CRM, transaction data, compliance documents, regulatory data, that was all on-prem. And then on cloud, of course, they had all their websites and annual earning statements and policy documents and so on and so forth. Okay, so in this kind of a query where there's a personalization, right? So there has to be various moving parts for a particular query, and it has to fetch various different parts of the data to actually answer the query holistically. In that case, you can see the flow, right? So from the branch app, the user will input the query. The query could be, hey, can you suggest a credit card which is more suitable for me? Then the query analyzer part comes in, okay, from the frameworks, the multi-agentic frameworks. It breaks down the query. It comes to know that there are two parts of the query. There's a cloud subquery from where I'm supposed to fetch the information for the banking products data, credit card data, retail products, insurance products. And then the on-prem subquery, because I'm asking personalization for myself, like my customer profile with the bank, then which means it has to go to the on-prem databases, and it has to actually retrieve my confidential data, transaction details, and so on and so forth. And then it will combine these two pieces of information together, the credit card which my bank has, all the credit cards which my bank has, it pairs it with the spending profile which I have, and then LLM will make a decision based on these two pieces of information, and it will give me back the result, right? So it will give me back the result. But you will see that the on-prem ecosystem is NVIDIA and the cloud ecosystem is Azure. So on NVIDIA, you have your Llama 2 models, your NVIDIA NeMo models, right? And on your Azure, you have your Azure embedding models and your Azure OpenAI GPT 4.4.0 or Omni, or whichever the flavor of model which you want to choose, right? And this is one of the still I'll say medium scenarios, medium complex scenarios. But then imagine call center analytics entirely, right? So you will have so many moving parts there. You will have a call summarization, call transcription, sensitive data. You will have follow up, like post call actions, during call actions, all of these things. And then when it comes to actually different agents orchestrating these separate diverse pieces of logic, then you can actually appreciate the kind of ease of interaction which frameworks like AutoGen and semantic processes bring. Okay, and let us see one such example in action for this particular scenario, this personalization query, on how different agents are actually working in tandem. So we'll first see the code, okay, code which is I'll show you how different agents are defined, and then we'll actually see the agents in action. All right, so let's jump into the code. Okay, perfect. So on my screen, you will be actually seeing Visual Studio Code, okay, where I have written my different agents. Okay, so as you can see, I have information agent, right? I have defined an information agent, which is basically it is actually it is agent which is helping the user with the comparison between different bank credit cards and so on and so forth. So this is your information recommended agent, which is actually going to get data from various websites based on the websites which are specified, right? So here it's a comparison between two banks, UOB, which is United Overseas Bank, and OCBC, which is Overseas Chinese Banking Corporation. So the scenario is that I have an existing OCBC 365 card, which is expiring, but I'm a customer of UOB. So I'm actually calling the UOB contact center and I'm asking them, hey, my OCBC 365 card was such a great card, and then but then it's expiring, and can you recommend me something similar from UOB suite of cards? Okay, so this is a scenario. And then as you can see, there's a personalized credit recommender agent. Okay, so it also has a system message and some actions which it is going to take. So this is personalized recommender agent, which is actually going to go to the database, my fetch my transaction and my customer details, and then accordingly look at what kind of spending profile I have. And I have other agents, like there's a customer assistant, there's a loan assistant, and um, uh, okay. So now you will be able to see here, for example, if you see the information recommender agent, which is our public data searching agent, I have given tools for it. Okay, here. So I what is the tool which is invoked? It is invoking Bing search. So Bing search with the other URLs, which URLs or of the websites which I ask it to search. Okay, so let's say if I want to compare OCBC credit card versus UOB credit card, it will be real time searching the OCBC and UOB data. Okay, real time. It's not canned data. It's not data which is pre-indexed. So it's actually going to go to the URLs of OCBC and UOB credit card data and crawl them real time and bring the information for me. Credit recommender agent is equipped with an action called get customer details, and get customer details is actually a function which I have written, which will be actually able to go to the on-prem database and get the customer details with the customer ID, right? And then you have again your a loan agent, which is able to actually so loan assistant agent, and then you have other. So what I want to show you is the plugins, right? The actions which your agents can take, those are defined by us. Okay, so your information recommender agent is going to invoke Bing search. Your personalized credit card recommender agent is going to invoke get customer details. Now which agent is invoked at what time, and how the agents hand off details to each other is then decided by the framework. So I have all these definitions given. I have defined those agents. You see now, AutoGen.group chat, I have provided all my agents here. Okay, this executor agent. User proxy is actually the user messages which I'm sending. Okay, the executor agent is the main agent, which is actually then going to give that user message to all the other agents, and then accordingly let them choose which agent is going to be invoked to process that particular piece of information. Okay, and so that's how it is. A definition of agents, the definition of the plugins of those agents, and then we let the framework do the rest. All right, so now let us take a look at behind the scenes what is happening. Okay, so how when we are invoking a particular question, when I'm giving a particular question, how the different agents are getting invoked. Okay, so let's have a look at that, and then we'll also see the application UI, right? So a chat interface, and then we will see that how beautifully all of this orchestration and all of this mechanism is totally not at all uh, of any concern to the end user. For the end user, it's just like, oh look, one expert is answering one of my messages, other expert is answering other part of my message. For me, it's totally absolutely not none of my concern of how the complex machinations and orchestrations are going on in the background. Okay, so we'll see both aspects, actually how these agents are interacting with each other, because I've logged the interaction of these agents while the APIs are being invoked. And then there's the entire web application also, which we will see, and then we can appreciate the differences. Okay, so here we go. Right. Okay, so let's begin. So actually I'm showing you all the logs which are being generated from the backend testing, right? So when the APIs are getting invoked, I am going to show you all the logs so we can see how it is fetching information which agent is being called, right? Okay, so you see now the logging has started, right? So logging has initiated, and as we'll be using Postman. Okay, so yeah, so they will be using Postman. So if you see Postman, I am actually giving a query, and the Postman, as you know, right, these agentic calls are all WebSocket calls. Okay, so my question is, my OCBC 365 card is expiring soon. It was a great card with 2% cashback options. Can you suggest similar options with UOB? So this is the first question the end user is asking the bot, right? Like, I have an OCBC card. It was a great credit card. It is expiring. Can you suggest similar options with UOB? So my first query is only about comparing my current OCBC 365 card with UOB cards, and suggesting something similar as my OCBC 365, which means essentially what the agent understands now is it has to fetch OCBC related data. It has to understand what OCBC 365 card does. It has to fetch UOB credit card data, and it has to basically compare and suggest the closest match from UOB set of cards. So we'll go to, right. So we'll go to the logs now, right? And you will see that the connection has been accepted. Connection is open. This is my query. I'm printing out my query. Okay. And perfect. Okay. So now you will see here, once my query is passed on to the AutoGen framework, then immediately the negotiation starts. Okay, and then it knows that based on the query and the prompts which the different agents have been given, it is invoking the information recommender agent. Okay, and suggested tool call. What is the tool call which I have given to the information recommender agent? It is Bing search. Okay, so basically it is going to invoke the tool which is Bing search. What is the query? Okay, so now you see that the query has been broken down by the framework itself into this intent. UOB credit card similar to OCBC 365 credit card. My query was now simplified into this intent. Okay, and then based on this query, it is actually now going to execute the information Bing search, right? So then what it is doing, it is going to the tool call, and then OCBC 365, I have given it the URL for, in the backend in the tool, I have given it the URL for OCBC credit cards. So it is going real time to that website. Yeah, it is going real time to the OCBC website credit card information. And then you see it is fetching all the details from there. It is scrolling that. It has gotten all the OCBC data, right? So title OCBC 365, and it has the other OCBC cards and so on and so forth. So it has gone to the OCBC data. It has fetched the OCBC data. Okay. It has also done the same thing for UOB. Okay. So if you see here on the screen, it has also fetched the UOB related data. Okay. Say similarly, right? So that it has, and then uh, based on all the data which it has fetched the OCBC, the UOB data. Okay, similar to the, yeah, here you can see UOB, right? UOB coupons, UOB cards, and so on and so forth. So it has fetched the UOB data as well. Okay, and then based on the information and the final ask is comparison of UOB cards versus the OCBC 365 credit card. Okay, so then it has actually combined that information, saying the UOB one card would be a competitive choice similar to your OCBC 365 card. Okay, and that is what it has come out with, the final answer. So UOB one credit card. So this, the information Bing search agent has searched the information. It has then compared the information, and then it has come out with a suggestion. So this is the suggestion. Okay, fine, fair enough. Now let us go to, and then you can actually see the information also being displayed in the Postman response. All right, so you can see the request response. Right now I'm going to go ahead with my second question. So I'm continuing the same interaction. Okay, And my question is, oh, thanks for the options. But based on my account and recent spend, can you suggest me some UOB cards that might be more suitable to me? So till the last interaction, what I was asking was OCBC 365 similar cards in UOB. Now I'm saying, oh, fine, but then the UOB one credit card, I was probably it was not appealing. That option was not appealing. And then I'm saying that, hey, based on my account and recent spend, can you suggest me something? So now same thing. Let us look at the interaction which goes on in the background. Okay. So from the WebSocket, it has gone back to the agent. The question is printed here. Okay. And then the credit recommender agent is invoked. Okay. And suggested tool call is get customer details, because now I have to, how will I get the recent spend? I'll get the recent spend based on the, customer details and transactions. Okay, so then it has given me the customer details and transaction spend and so on and so forth. Okay, now it is also when it is fetching the data, when it is fetching my data, it has also identified that the existing account which I have is a travel loan. You can see here, right? So I also have a travel loan with the bank, so I have some loan with the bank as well. Okay, and then if the recent transaction also says some loan payment and amount of the loan and transaction date apart from the other transactions I may have had with the bank. And then that's how it says that based on your recent transaction and spending pattern, notable expenses are directed towards travel related activities. Okay, and that is why it has then suggested me some miles visa card, or it has suggested me some UOB ladies card. And then it also proactively says that given that you have a personal loan with us, if you apply for one of these credit cards, then we can also waive off your interest rates and discounts, and then some promotional offers we will be probably offering to you, extending to you. So these kind of things. And then also says that don't worry, I'm going to send all of this information to you in an email right here. So here I would suggest reviewing potential interest rate discounts and overall expense repayment and so on and so forth. And then it says that, okay, you don't have to worry about all of these things. I'll give you all this information in a email. And then probably there's an email agent which is triggering the email action and sending out the email. Okay. So, okay, fine. Now yeah, so now if we move forward, right, these are the kind of things. So you can see, right, so credit recommender agent, information recommender agent, and then finally what my yeah, so then I'm now it has suggested me credit cards. Now then I'm asking it another question: what is the room for me to request for a home loan? This will be on top of my current loan. Okay, so then it has to again, because it already knows and we know that it has memory, it has the memory of the past interaction, so it already has fetched my transaction details. So it knows how much is my loan amount and how much I have defaulted or not defaulted. Okay, and then it is then going to, first of all, it is going to the information agent to fetch all the UOB home loan products which are available. Then it is combining that with the loan assistant and the customer profile details which were filled earlier. Okay, and then it is going to suggest me, yes, so your home loan eligibility, what is your home loan eligibility, and can you request it on top of your current loan? So all that details will be fetched. So you can see multiple agents in action. The first in this particular interaction, where it is asking for what is the room for me to request more loan, then first of all it has gone to the information agent to get all the UOB home loan offerings, and then it has gone to the loan assistant agent to actually combine that home loan with your current loan and your loan eligibility, and then giving you an answer. The loan assistant is giving you that answer. All right, so it can be single agent, it can be multiple agents, it can be handoff, output of an agent could be the input of another agent. It could be parallel agents getting invoked at one point of time. So you can have agent chaining, you can have parallel agents, you can have multiple agents feeding to one agent, or one agent feeding to multiple agents. So there are a lot of design patterns possible, and there are humongous possibilities also with all of these different interacting patterns between agents. Okay. So now we have seen the backend part of this, right? Let us have a quick look at how easy the front end is. I mean, how seamless the interaction on the front end is for this kind of a scenario. Okay. So if we just look at this particular exact similar interaction, but in a UI, right? So here you can see I'm your chatbot assistant. How can I support you today? Same thing. My OCBC is expiring. Can you suggest me similar UOB card? I just will see that, the credit recommender agent saying, hey, wait, I'm checking for you. And then the recommender agent itself is giving me all of the information. Okay. All that handoff, what is happening, what website it is searching, it's all, I don't care about that. The end user doesn't care about that. It just gets the final answer. Also, same thing. Does the UOB credit card has a fee waiver offer? Then again, the agent is saying, yeah. So this is a way kind of a signal where the negotiation between agents is happening. Then the credit recommender agent again comes and then says that, yeah, it has a fee waiver and the annual fee can be waived by meeting specific pending spending criteria over a certain period, and so on and so forth. Okay. I can continue the chat, okay, and then you'll be able to see that same thing. See, I hold a UB account and I'm interested in a personal loan. So then the loan recommender agent comes into picture there, and then it will be interacting with the other percepts which is getting from the past conversation, and then accordingly it will be able to recommend me stuff. Okay, eligibility requirements, then extra cash. So as you can see, right, I'm changing the color scheme of the agents just to show that different agents are getting invoked. Okay, but apart from that, it is just like any other conversational chatbot for me, right? It's just that different experts are jumping in to help me real time and then addressing my queries. So on the UI, you are able to see that this is nothing different than me chatting to a normal LLM chatbot. Okay, but in the back end, you can actually see how beautifully all the negotiation is happening, what all is taking place, how the query is being broken down dynamically into different intents, and how that orchestration happens, right? So with that, we are at the end of our yeah, we are at the end of our session. And if there are any questions, I would be happy to take. I'll be sharing the slide deck. I'll also be sharing the GitHub repository where this the demo code is hosted, so that you can actually set up your own agents, set up different prompts. You can choose whichever credit cards and banking information you want to interact with. And thank you so much, guys. Thank you for joining me, and enjoy your agentic journey.
Yeah, it looks like we do have a couple questions in the comments,
Sure.
so I can pop them up
Happy
here.
Happy to.
So I don't know if you can see it, but looks like Alex is asking when to use semantic kernel versus AutoGen.
Yeah, so that I think I covered earlier itself. When do you use semantic kernel versus AutoGen? Okay, so semantic kernel is a framework for building RAG applications, RAG applications, as you can see here. Okay, so I would the demo which I showed you earlier, which was this insurance lodging bot, that was built using semantic kernel, right? And all these single agents, the loan agent, the information gathering agent, those all could be built using semantic kernel, and the orchestration happens using AutoGen. So if I just go back to the code and I show you all these agents, okay, now here I have given them only some system prompts and actions, but all of this information recommender agent, that entire agent could be an application which is built using semantic kernel. This personalized credit card recommender agent, it could be an application which is built using semantic kernel. And then these different agents are orchestrated using AutoGen. So I hope you get that. And now semantic kernel processes also. So semantic kernel processes will be able to orchestrate the agents which you have built. But yeah, so these single intelligent pieces of logic are semantic kernel. Orchestration is using AutoGen.
All right, thank you. It looks like there's a couple more questions in the comments, but just for the sake of time, we will let you go. And if you maybe can swing back and just address those when you get a moment, that would be great.
Absolutely.
Priyanka, thank you so much for that. So we will let her go. And I would like to thank everybody for joining us today. We always appreciate it, and we definitely appreciate your feedback. So if you could take the time and fill out our survey, we would greatly appreciate any feedback that you have to give. And the key for that is just referencing the event code, which is 24659. Once again, that is 24659. Thanks so much. We look forward to seeing you on the next event in this series, and have a great rest of your day. Thank you.